Okay, so this is the Chapter 8 test review. We're just going to go through and start graphing. I'm going to go ahead and I'm going to put in sort of my x-axis and my y-axis and my x-axis. Let's get those drawn in. Excuse my imperfect drawing skills, but anyway, as we go to do the horizontal asymptote, we look to see if it's bottom heavy or balanced. This is an x to the first over x to the first. That makes it balanced, so I look at these leading coefficients right through here. I've got a 3 over 1x, which makes my horizontal asymptote be at 3. So if I were to grab up here at 3, so I've got up 1, 2, 3, I should be able to, that's a little big. I'm not going to use that. Let's undo that. Oops. Let's use something a little thinner. Up at 3. Alright, I'm going to have my, I am struggling today. We got to pick a different color. Alright, we're just going to go here. There we go. Up here at 3, I'm going to have my horizontal asymptote. For the vertical asymptote, it always comes about making the bottom equal to 0. Since x minus 4 is all that I have on the bottom, 4, positive 4 would be my vertical asymptote. I'm going to come over 1, 2, 3, 4, and I'm going to draw my dotted line up and down through 4. Okay, so there's my horizontal and vertical asymptote. The domain x cannot be 4. That's an unacceptable value. Now, I said earlier that there'd be some extra credit, and if the top can be made to equal 0, there is what's called an X-Intercept. If you think about 3x minus 6 being equal to 0, we would add 6 over, so we get a positive 6, and if we would divide it by the coefficient of the x to 3, 6 divided by 3 is equal to 2. So this should cross the x-axis right here at 2. Okay? Whatever happens, I should have a crossing right there. Okay, so now I go to do my actual graph. It might be in our best interest to actually look at a calculator. So I'm going to pull this calculator over, go to y equals. Remember that when you're using the graphing calculator, if you want the fraction function, it's alpha y equals, that n over d. And that lets me write 3x minus 6 over x minus 4. And when I graph that, I get the curves down here and up there. So I'm just going to try to mimic that image by following the boundary line, right? Curving through, I should go through that x-intercept, and then I follow this boundary down, right? And then over here, I'm going to follow the boundary up above, like that. Okay? So that's our whole graph completed with domain restrictions and my horizontal and vertical asymptotes. Here I have an x to the first over x squared. That's bottom heavy, so my horizontal asymptote will be 0. That's always true if the denominator is bigger. The vertical asymptotes, I'm going to have to factor this. Oh, before I get going any further, I wanted to change this problem on the test review to an x plus 3. There's a reason for that you'll learn more about in pre-cal or college algebra. I really need this to be an x plus 3, not an x minus 3. That was my bad on the original building of the test. X and x, how do you split a 15 so that you can subtract and get 2? That would be 5 and 3. Make my 3 look like a 3. And the 15 is negative, so the signs are different. I'm going to go plus 5, negative 3. So my vertical asymptotes would be at negative 5 and positive 3 because we switch the signs when we pull them out. So x cannot be at negative 5 or at 3. So now let's grab a different color. Let's make it a little bit thicker. Get my two axes in here drawn. And let's change the color again. We'll go red. This will give me my horizontal and vertical asymptotes. Horizontal asymptote, it's a little hard to draw on top of the x-axis. Use colored pencil when you're doing it if you want, or just extend it past the graph. I'll generally be able to see when you put them in there. And then over here at negative 5, 1, 2, 3, 4, 5. Okay, so my graph's going to have 3 pieces to it. a left, a middle, and a right. Would the top ever equal 0? It would equal 0 if x equals -3. So x is -3, 1, 2, 3. Should be right there. I should be crossing right there on the x-axis. Again, those are going to be extra credit points when I give you your test. All right, let's pull this over to this side. Up on top, I want x plus 3, and on bottom, I want x squared plus 2x minus 15. And if I graph that, it's not perfectly ideal, but you can see that there's a curve here on the bottom left, and then if you remember that these zigzag sometimes through the middle, you can see the sort of zigzag and then that curve to the right. So I'm going to go ahead and create that image by following this first graph in this area. I'm coming down, I'm going to cross through here at -3 and then zigzag my way down. If you don't know exactly where that crosses, you can still cross wherever. I just won't give you the extra credit for knowing exactly where it's supposed to cross. And then this graph over here follows that. If I go back to the calculator image, hopefully you can kind of see, oh, okay, I see the 3 parts. There's this curve here, then there's the zigzag through the middle, and then there's that last curve on the upper right. Okay, so those are the graphs. Everything else is going to be about factoring and LCDs. When we're simplifying on number 3, it's all about factoring. So I'm looking at these. This first one is an x squared with a number, so that would make me think of 2 parentheses. Okay. On bottom, I don't have that last number, so I think that's just a 1 parentheses problem. So let's go ahead and factor these two as a contrast. X squared would of course split as x and x. How do you split a 9 so that when you subtract you get 0 in the middle? It'd be 3 and 3 with a plus and a minus. Well, what does x squared and 3x have in common? Well, they both have an x. If I pull that out, that leaves me with an x, and I pull an x out of the 3x, I get plus 3 times, that's what this symbol here is, and these are going to be double parentheses on top and on bottom. So I get x and x. Factors of 5 would be 5 and 1. Signs are different. To get a -4, I'll go -5 plus 1. And down here I get x and x. Factors of 3 are 3 and 1. Signs are different. I need a -3 and a plus 1. Now I can come through and say I've got an x plus 3 over an x plus 3. I've got an x minus 3 and an x minus 3. I've got an x plus 1 and an x plus 1. The only thing left is x minus 5 on top and x on bottom. There we are. Over here, number 4, the thing we have to remember is that when we do division, we've got to keep the first fraction. We'll keep it exactly the way it is. But we're going to switch to multiplication and flip the second fraction. So when I go to factor this, I'm going to remember to factor the second one upside down. We'll do that in just a second. X squared is going to be x and x on all these. What are the factors of 6 that subtract to give me 1? That'd be 3 and 2. Signs are different. I'm going to do a plus 3 and a minus 2. This x squared minus 9, we already factored it. It's a plus 3 and a minus 3. My x plus 3s, those will cancel. Okay, now when I factor this, I've got to factor it upside down. So the bottom part goes on top. I'm going to go x and x. Factors of 2 that minus to 1 would be 2 and 1. And since this is a positive 1x, I'm going to go plus 2 minus 1. On the bottom, I'm taking the top up here. I'm going to have x and x. Factors of 2 that add up to 3 are 2 and 1. The signs are the same because the 2 is positive. To get a -3, I'll go minus and minus. Here I see an x minus 1 and an x minus 1. I see an x minus 2 and an x minus 2. Again, we're doing top to bottom. That leaves me with an x plus 2 over an x minus 3. Okay? All right, we're getting there. All right, question number 5. On question number 5, I'm just asking you to find the LCD. I don't need you to do anything special, but you do need to factor it and then say, what would a common denominator for these two be? Here I get x and x. Factors of 10 that subtract to 3 are 5 and 2. And then signs are different, so I'll go plus 5 minus 2. Over here I've got x and x. Factors of 20 that subtract to 1 would be 5 and 4. Signs are different, so I'm going to go plus 5, minus 4. When I go to build the LCD, I have to remember that I'm saying what can I make both of them look like by multiplying by other stuff. So usually we just take one of them. So I'm going to take this one on the left, x plus 5 times x minus 2. That's one of my denominators. But the problem is this guy over here has an extra piece of information that I don't already have. So I'm going to put an x minus 4 here. And then you could ask the question, if I had to make these two fractions look like this, this guy would need an x minus 4, and this guy over here on the right would need an x minus 2. But if I did that, both denominators are the same, so this would be my LCD. I don't need you to do anything else with it, just need to know that you know what an LCD is. Down here, we want to be able to add these two fractions together, which just means we need a common denominator so that we can add the top. The LCD on number 6 would be x minus 5 times x plus 3. We're just going to have to combine them. Well, that means this fraction here is missing an x plus 3 on top and bottom. And this fraction over here is missing an x minus 5 on top and bottom. Will both denominators now have the exact same thing in them? Yes. So that means we're ready to go. Whatever we do is going to have this x plus 3 and x minus 5 in it. That's the denominator for everything that we're going to do the rest of the way. X times 2 is 2x, and 2 times 3 is plus 6. I'm going to add to that. 5 times x is 5x, and 5 times negative 5x times, sorry, that's 5x squared, my bad. 5x times x is 5x squared, and 5x times negative 5 is negative 25x. That's all over, again, our x plus 3, x minus 5. And if we combine any like terms across the top, we get 5x squared. The positive 2 and the negative 25 makes negative 23x. And of course we have our plus 6 all over x plus 3, x minus 5. Number 6 is going to have the LCD show up in the answer. These other questions, 7, 8, 9, none of them will have the LCD in the answer. But 6, because we're just trying to add two fractions, we're going to get the LCD to show up. It's not going to just disappear on us. All right, let's take a look at number 7, 8, and 9. It's really all about the LCD. On number 7, the LCD would be x plus 2 times x plus 3. You can see because we have x plus 2's and x plus 3's everywhere. If we multiply each one of these by the LCD, one part of the LCD is going to cancel. So for instance, this first fraction, the x plus 2 will cancel in the LCD, but that means I still have to multiply by x plus 3. In the second fraction, the x plus 3 cancels, which means I still need to multiply by x plus 2. Down here, the x plus 3 cancels, but I still have to multiply by x plus 2. And here the x plus 2 cancels, but I still have to multiply by x plus 3. Okay? So we still have these other multiplications to do. 3x times x is 3x squared. 3x times a 3 is plus 9x. We have plus 2 times x is 2x, and 2 times 2 is plus 4. That's the numerator of my fraction now. On the bottom, x times x plus 2 would be x squared plus 2x, and 3 times x plus 3 would be 3x plus 9. If I can combine any like terms, we want to do that. So we get 3x squared plus 9x and 2x is 11x plus 4, and that's all over x squared plus 5x plus 9. And that right there is my simplified version of the problem. Okay, we've just got two more. I'm actually going to do number 9 right now because it's the same basic principle. The LCD on number 9 is x times x plus 4. And we're going to do the same multiplication on all three of these pieces. Again, we have the equal sign, so we can multiply the left and the right by our LCD. The x plus 4 is going to cancel in this first spot, and I'm going to have to multiply by x. The x is going to cancel in the second spot, and I'm going to have to multiply by x plus 4. And the x plus 4 is going to cancel in the second spot, and I'm going to have to multiply by x. Well, x times x is x squared. 3 equals 3 times x plus 4 would be 3x plus 12 minus 4 times x is 4x. Because I have an x squared, I want everything on the same side, so I'm going to have x squared. A negative 4 and a positive 3 is negative x, but if I move it to the other side, that would be a plus x. And if I move the 12, it would be minus 12 equals 0. If I factor this, I get x and x. The 12 splits as 4 and 3 because I want a difference of 1 here in the middle. That gives me a plus 4 and a minus 3, meaning that my answers would be 3 and negative 4. But I have to confirm that they don't make the denominator equal 0. Because the original denominator had an x plus 4 in it, the negative 4 needs to be rejected, and only the 3 is kept. Over here, we have a straightforward cross multiplication problem. 2x times x minus 2 is 2x squared minus 4x. And that will equal x times x plus 3, that's x squared, plus 3x. Because I have x squared in the problem, I want to move everything to the same side. So I'm going to minus x squared and minus 3x, minus x squared and minus 3x. That would give me x squared minus 7x equals 0. Because I'm missing that last term, it's just a GCF factor. So pull an x out, gives me x minus 7. So my two numbers would be 7 from the parentheses, and this guy right here, when there's an x that got GCF factored out, is always 0. Now, I do want to make sure they don't make the bottom 0, but that would be at negative 3 and at positive 2. I'm not worried about those at all, so I can keep 7 and 0 as my final answer. Good luck, guys. We'll see you in class. I hope we all do well.